is Gregory Miller, and this is my video for my Mousetrap car project. So, here's my Mousetrap car. I have two different sized wheels. I have GameCube sized wheels, and then I have normal regular CD size. So, I have two GameCube size in the front, and then two regular in the back. So, my Mousetrap car base is a wooden plank of 4 inches by 8 inches. And then I have the Mousetrap, which is glued on. And then I have a pencil that's taped, connected to a fishing line, connected to the back axle, with which is a Tinker toy as long as these two. I keep the CDs in place by rubber bands, and there's also another Tinker toy here. So my experiment, how I wanted to go, is like, how would the shape, size of the back wheels of the axle, where the force of the Mousetrap is getting transferred to here so it can move the axle, like, how would the size matter? So I built my Mousetrap car in the design where I can easily take off the wheels and put them back on, and so I can interchange these wheels with these wheels. So I could test and see the distance between bigger wheels or smaller wheels in the back axle. So let's go see how the distance are for the back wheels. So let's see how this goes. Alright, 3, 2, 1. So, as you can see, it hit the wall there, has a slight turn. That's mostly from the rubber bands. It went a fairly far distance in this hallway. So, I'm going to switch the wheels and see what the distance covers then. Okay, that took about 5 minutes, fairly fast. So, let's test and see. As you can see, that it's changed because the smaller wheels are now in the back. So, let's test the distance and see how far it'll go. And I'm just going to note, this is the first time I've actually had it in this configuration. So, basically what we're doing here is experimental. So, let's test how this goes. Well, as you can see, it did seem to accelerate a tiny bit faster than the other one. However, the distance traveled was a bit less, because if you remember the first trial, it did hit the wall in the corner. So I can say the steering is a bit better in the back. The steering-wise, it's not as bad as it was the first time. However, the distance is a bit farther, because if it didn't crash in the first trial, I believe it would have at least gone past the doorway. So therefore, my conclusion is that by having bigger wheels in the back, it covers more distance. But by having smaller wheels in the back, it covers less distance but goes faster. This is a result of the circumference, because as you can see, the string, it has the same amount of revolutions right here. So that means this goes around faster, you can say. Like, the revolutions are really kind of slow. So, I mean fast. Sorry, wrong word. And so it seems that it goes faster because of that, and since these are a lot bigger, it covers more distance but goes a bit slower.
Any final words, Greg, before we leave off of this video?
I like my car.
Okay.